All right, here in just a moment, we'll be taking a quiz over what we've been working on in these last couple of lessons, working with trig equations. I've got 4 problems for you here on the chalkboard. Take just a few minutes to work on these, and then we'll go over them together. We'll be working diligently on these trig equations. Remember, you're solving for all possible answers, so make sure we think through ASTC in our answers as well. Make sure if you take a square root, we put the positive, negative, and things like that. Take a few minutes to work on these, and then we'll go over them together. Remember, isolate the trig function, get it by itself. I'm going to pause where you're at for just a moment. I'll let you continue working in a moment. But I want to look at this first problem with you. What do I do first here, Chris?
You need to set it equal to 0.
Well, I don't have multiple trig functions, and if we want to think of it as a quadratic, which it is, it's incomplete.
Yeah,
so
what I did actually first was what it is. I divided the 2 over, and from the sign, and I got 1. So
oh, careful. So if this said 2x squared plus 1 equals 2, what should I do first?
Set it equal to 0?
No, it's not a complete quadratic. It's incomplete. We want to isolate this x squared. We want to get it by itself.
So you would minus the 1 over?
There we go. This is less attached than the 2, remember. So we're going to subtract the 1 from both sides to get a 2x squared equals 1. Then we would divide the 2 away to get x squared equals a half. And then finally we would...
So
that would give you x to the square root. Take the square root. All right, so we're going to do the same thing then on this. The first thing we ought to do is
minus the 1 away.
Subtract the 1 to get 1, then divide the 2 away to get a half, then take the square root to get the sine of phi equal to, and our idea to take the square root, class, positive negative square root of a half. Now, you can't take the, or you can take the square root of 1, class, that's just 1. You can't take the square root of 2, and normally we rationalize this, right? We'd multiply, get square root of 2 over 2. We don't need to, though. We can just ask ourselves, when is sine, which is whatever what, class?
Opposite over hypotenuse.
Opposite over hypotenuse. When is sine 1 over square root of 2?
45.
At 45. But because of the positive negative, ASTC, which quadrants? All 4. So we want all 4 45-degree angles, Ethan.
45 degrees. I had 2 of these. Mine was 215.
So you forgot the positive. Well, you had quadrants 1 and 4, it looks like.
225.
225 in quadrant 3. Anyone?
220.
135 in quadrant 2. So these two are because of the positive, these two are because of the negative. The sign's positive and these two negative and those two. Should have had all 4 answers. All right, so questions on this first one before you continue working? All right, keep going. I'll give you a few minutes and then we'll go to the next one. You done with all 4? So if you are finished, I do have a 5th that we will work. All right, once again, go ahead and stop where you're at. Let's take a look at this second one you did. And here, there's 2 different trig functions in the same equation. What's the key going to be here, Quentin? Here we've got to set it equal to 0 and then...
factor out the tangent.
There we go. So we're going to start by bringing the tangent alpha over as a negative. And then said we do what, Jamie?
Then we're going to factor out the tangent.
All right, so we get tangent alpha times...
cosine alpha minus 1.
And then once we've factored out the tangent, we've got it factored, then what do we do, Ethan?
We set it equal to 0.
Set each factor equal to 0. So we'll say that the tangent of alpha equals 0, and we'll say the cosine alpha minus 1 equals 0, but I'm too lazy to write that. Instead, I'm going to say cosine alpha equals, Chris, positive 1. My suggestion, you'll recall, is if it isn't a fraction or a ratio, make it by putting it over 1. And I also had a tip on 0. Anyone?
Positive, negative.
Put a positive, negative. It's neither positive nor negative. We could think of it as either positive or negative. So then the question becomes, when is tangent opposite over adjacent 0 over 1? Anyone?
0.
At 0. But positive, negative means 0 and its inverse, 180. So alpha is going to be 0 degrees and 180 degrees. Then, when is cosine adjacent over hypotenuse 1 over 1?
45 degrees.
90 degrees.
Adjacent over hypotenuse at 0 degrees. And notice just a positive, so not the 0 and 180, just 0. However, you notice there's overlap? So we don't really need both sets of answers. We could just say this, because 0 is simply a redundancy. We'd already said that alpha was 0. Questions on this one? Yes, sir?
I had cosine times tangent minus 1. I don't know how I got that. So I got my answer like backwards.
Okay, does it make sense what you should have done?
Yeah.
All right, any other questions on this one where there's multiple trig functions factoring set equal to 0? Or set equal to 0 and factor. All right, keep working.
I have a question about the problem you just put there.
Are we there yet? Do your best on it. We'll get to it in a little bit, but for now, work on the other ones. And we'll get there. In the next problem, class, we see multiple trig functions, and usually if we see multiple trig functions, our strategy is to set it equal to 0 and factor. Thoughts? It's already set equal to 0, it's already factored, right? So we're ready to do our next step, which is to take each factor and set each factor equal to 0. But I'm too lazy to actually, do all of that. Instead, I'm just going to say that the cotangent of gamma is equal to negative square root of 3 over 1. And here, that the tangent squared gamma is equal to 1, which means that tangent of gamma equals, which is 1. And anytime you take the square root, we got to put a positive negative 1 over 1. Questions getting to that point. All right, so then it just becomes a question of when is adjacent over opposite square root of 3 over 1? At 30 degrees. But when is cotangent negative ASTC?
2 and 3. Or 2 and 4.
2 and 4. So I need the quadrant 2 form of 30 and the quadrant 4 form of 30 for gamma.
150 and 330.
150 and 330. Those are my first two answers. Let's come over here now. When is tangent opposite over adjacent? 1 over 1. 45. The two legs are both 1 at 45, and positive negative means what quadrants? Yeah, all 4 quadrants. Get my reference angle of 45 degrees. So 4 answers for gamma.
45, 135, 225, 15.
And so we end up with a total of 6 answers for gamma on this one. How many had those? All right, Ethan, good questions from the rest of us.
Just on the first one, I said 210 instead of 330.
Okay, all right, questions on these? Go to the next one. Looks like we're all finished with that one. Jamie's still working. Guys, you all finished with the last one as well. If not, working on the beta problem. We'll look at lambda once Jamie's finished. Unless she takes too long, then we'll just look at it. In this one here, we don't really have multiple trig functions because they're just secants, right? There's a secant here, there's a secant there. The problem is that there's 2 different secants, and you can't have that, right? But I don't need to set it equal to 0 and factor. Instead, I just need to get rid of the little one, right? Just like if I had a 5x and a 3x on opposite sides, I get rid of the little x. Here we get rid of the little secant, Jamie, by putting a?
By moving over as a 2 secant.
I move this over as a negative 3 secant to get 2 secant lambda. Minus 3 is equal to 1, or you put a negative 3 secant on both sides. But yeah, my brain is stuck in algebra 1 and pre-algebra mode where we don't move things yet. And then from here, Chris.
Plus the 3 divided 2.
There we go, plus the 3 to get a
4. And
then divide the 2 to get a. So we end up with a secant of lambda is equal to 2. Now notice that's just what SIGN class?
Positive.
Just a positive. Let's put it over.
1.
And remember the secant's what over what class? So when is the hypotenuse 2 and the adjacent a 1?
60.
At 60. But ASTC, secant's positive. 1 and 4. So I only want the 1 and 4 forms of 60.
63.
And there are my 2 answers for lambda. How many had those?
I would have had it, but I had 30 as the angle.
Okay, careful with your triangles. Again, we have the adjacent is 1. Hypotenuse 2. Well, what angle's adjacent to this? This guy right here.
I thought that was 30. I don't know.
Okay, yeah, this is big, this is little. All right, and then the last one here, working there at your seats. Some of you already finished. Since you have big powers, we have to set it equal to
0.
Yeah, it's not technically quadratic, but, you know. Slip it in there. Thoughts once we've set it equal to 0, Chris?
What I did is I made it 4 cosine cubed minus 4 cosine squared in parentheses.
There we go. Let's group these together, right? Factoring, we set it equal to 0 in factor, but the factoring is going to be by grouping. And in the first group, what did you do?
I took out a 4 cosine squared, 4 cosine squared, parentheses, cosine minus 1. And then the next one I pulled out a 3.
Well,
technically you can cancel the 3.
you can't cancel them, but there's a negative first term, so we want to actually pull out a negative 3. And that's going to be important so that you're left with
cosine minus 1.
Right, cosine minus 1. If you try to pull out a 3, you'll have a negative cosine plus 1, which isn't similar. Right? And then, Jamie, in these two terms,
we have, now we can make an equation with 4 cosine squared beta minus 3, and then have the cosine beta minus 1.
there we go. The cosine beta minus 1 is the common binomial, leaving us with a 4 cosine squared minus 3. We'll set each of these equal to 0 to get what two little equations? Ethan?
Cosine beta equals 4. Square root of 4.
There we go. Positive, negative, square root of 3/4, which you can't take the square root of 3, but you can take the square root of 4. There we go. And then we can also get from here the cosine of beta equals positive 1 over 1. All right, then from here, Quentin, we'll say, well, when is cosine adjacent over hypotenuse? Square root of 3 over 2.
30.
At 30 degrees, and because of the positive negative, ASTC.
All 4 coordinates.
All right, so that's going to be 4 different 30-degree angles.
30, 150, 210, 430.
And then here, Jamie, we've got a 1 over 1 adjacent over hypotenuse.
Would that be 90 degrees?
Well, let's see, would it? We've got, here's the true 90, here's my fake 90, my fake 0, 1, 1, and 0. I want the adjacent to be 1 and the hypotenuse to be 1.
Would that be 0 degrees?
There we go. The hypotenuse is always 1, but for the adjacent to be 1, that would have to be the 0-degree angle. And not positive negative, so not 180 as well, just 0. We get 5 beta angles here. How many got those 5 beta angles? I know, Jamie, you were still kind of working it with us as we did it. Gentlemen, good to go? All right, questions at all on this? Any questions on solving these trig equations?
Can we do a few more problems before we take the quiz?
I think we've done enough. Any questions on these? All right, clear your desk then, if you would please, except for a clean sheet of paper and a pencil. Calculator's optional. You're welcome to use it if you feel you need it.
Can you show the way how to do arcsine or cosine we're using it instead of?
You won't need to use your calculators for this. The calculator's just there for comfort. All of the angles will be special angles on here if they work out at all. Okay, there won't be one of those where you have to get a crazy decimal on the quiz. My focus is primarily using those special angles. First, I'll see you at the top of your paper along with today's date, which is 11/29/21. 11/29/21, today's date. And this is quiz 21. 11/29/21, today's date.
21.
And this is quiz 21.
Oh no.
All right, pretty straightforward. There are 4 trig equations for you to solve. Solve them. Carefully and accurately. We'll resume the video after the quiz.